The Fluke 90 digital tester is a versatile field and depot service tool which can be used as an adjunct to a logic analyzer, oscope, or logic probe to diagnose many common faults in microprocessor-based equipment. This videotape will show you how easy it is to put the Fluke 90 to work, even before you study the manual. The Fluke 90 is small enough to fit in the palm of your hand, yet its powerful features can save you countless hours as you test and repair microprocessor-based devices. Each Fluke 90 supports one and only one type of microprocessor, as indicated on the front of the instrument. That's the first thing to remember. Second, the UUT must have an operational plus 5-volt power supply, or you must connect an external power pack to power the Fluke 90, independent of the unit under test. Third, unless an external power supply is used, the UUT power supply must be able to supply current to the Fluke 90. The Fluke 90 adds a maximum of 150 milliamps of load to the UUT power supply. Before connecting the tester to a UUT, test its 5-volt power supply. The Fluke 90 should not be used when the UUT voltage exceeds 6.3 volts. In this case, the UUT power supply is satisfactory. Turn off power to the UUT before connecting the Fluke 90. Now, connect the Fluke 90, matching pin 1 on the UUT microprocessor with the white dot on the Fluke 90 clip. Now, turn the power back on. The Fluke 90 now automatically runs a number of self-test routines. If the display contrast is poor, adjust it with the control in the lower left of the front panel. When the self-test routines are complete, this is what you will see. The Fluke 90 is ready to go to work. The UUT in this video is very similar to the devices you will be repairing. For the purpose of this demonstration, switches have been added to introduce faults in the circuitry. This UUT includes all typical components, including the kernel, the UUT's address, data, and control buses up to the microprocessor buffers, the buses beyond the buffers, the UUT's ROM and RAM, and peripheral devices accessed through I/O or memory addresses. From the Fluke 90's keyboard, you can access 4 groups of built-in test routines: bus tests, memory tests, I/O tests, and probe tests. In most instances, you will use the bus tests first. Test bus verifies that the kernel's address, data, and control lines are free to be driven by the UUT's microprocessor. The test forces bus lines to specific states, one at a time, then checks to see that the line is free to be driven both high and low, and that other lines are not shorted to the line being forced. Press Enter to begin the test. If no faults are found, the display will read, "Test completed." If errors are found, a message appears indicating the name of the faulty signal and the problem. We will simulate a problem by throwing this switch. Run the test again by pressing the Enter key. Now let's consider the Fluke 90's repertoire of memory and I/O tests. Most of these tests operate in what is called a DMA cycle stealing mode. The Fluke 90 tests RAM and ROM, writing to and reading from memory and I/O addresses without interrupting the UUT's normal operation. You can test memory or control peripheral devices while you apply mechanical or thermal stress, or you can test while you vary the output of the UUT's power supply. The Fluke 90 offers 6 memory tests. 2 of these tests, test memory and memory checksum, are best used to confirm that your UUT's RAM and ROM are functioning properly. Let's use test memory as an example. Test memory should be used to check the UUT's RAM. To run the test, select Test Memory and press Enter. Select a start address. Then press Enter. Select the end address and press Enter once more. The Fluke 90 will now write, read, and check data in each cell in the range specified. If no fault is detected, the tester presents an OK message. If a fault is located, the display indicates the address of the failure, the test pattern that the Fluke 90 attempted to write, and the contents that were read back. After successfully running the test, you can run the test again simply by pressing Enter. Or press Loop to run the test continuously. Memory checksum should be used to test the UUT's ROM. As you did before, press the Memory Test key to scroll to the desired test. Then press Enter. To specify the test range, select the start address and press Enter. Select end address in the same way and press Enter once more. The Fluke 90 will now sum all data in the specified range, then display the total. This figure will equal the sum generated by most EEPROM programming equipment. After completing one pass, you may want to run the test again. Which key would you press? What key would you press to run the test continuously? Memory checksum can also be used to check for improper RAM, ROM, or I/O address decoders. To do this, set the checksum range to cover a single memory chip or set of chips. Set the test to loop continuously. Then use the probe to check the chip select lines of all other RAM chips, ROM chips, or I/O ports. Since the Fluke 90 synchronizes the logic probe to memory write or read cycles, activity on any other chip select lines may indicate faulty address decoders. 3 of the other memory tests allow you to read from and write to UUT memory space. With these tests, you can read or write data values from memory or memory-mapped I/O devices. Memory Examine lets you look at the value at selected memory addresses. Memory Verify lets you write a data value to a selected memory address and perform a read after write to ensure that the intended value was actually written. Memory Write writes a data value to the selected memory address. No read after write is performed. All 3 tests are started in the same way. For instance, if you selected Memory Examine, simply follow the prompts to enter the memory address to be read from or written to. Then press Enter. The display will now show the contents of the selected address. If you asked for Memory Write, the display will show the value that was actually written. If you chose Memory Verify, the display will show the value that was written, but if the value read back does not match the one you entered, the display will show a failure message. When the test is done, press Enter to read from or write to the next address. Or press Loop to run the test continuously. Do you remember how to stop a test that is running in loop mode? The last memory test is Memory Soak, which tests the ability of static RAM to retain data for extended periods of time. Enter the start address. Enter the end address. Enter the test data. Finally, select the soak time, anywhere from 0 to 99 minutes. If no fault is detected at the end of the soak time, the Fluke 90 presents an OK message. If errors are found, the tester indicates the address of the first failure. Press Enter to display all of the error messages, one at a time. In addition to the memory tests, the Fluke 90 offers 3 I/O tests for those microprocessor types with an I/O address separate from memory addresses: Examine, Verify, and Write. These tests perform similarly to the memory tests, except that they access I/O addresses. With them, you can read from or write to any location in your UUT's I/O address space. Look at the case bottom decal to note the I/O address range. One way to check the condition of the UUT's bus outside the kernel is with the Fluke 90's 4 probe tests: Quick Trace, Probe Address, Probe Data, and Probe Control. These tests use the logic probe to automatically identify nodes on the UUT's address, data, and control buses. Quick Trace and the Probe Control test may not identify all control lines for your microprocessor, so check the decal on the bottom of your Fluke 90 for the list of control lines identified. The quick trace test automatically identifies the node the probe is touching. In this test, the Fluke 90 exercises the data, address, and control lines and searches for corresponding activity at the probe, so you can trace a suspect bus line through the UUT and identify problems, such as shorts or opens. To execute the test, select Quick Trace and press Enter. Touch the probe to a node on the UUT bus. The probe lights will change from red to green, and the display will indicate the signal line probed. If the light stays red, and you're sure you're touching the proper line, you know that something is wrong with the signal line. It may be disconnected from the microprocessor, shorted to ground, or shorted to +5 volts. If both lights come on, you know that more than one signal was found to be connected to the point touched by the probe. Look at the display to see the names of the signals. Note, this may be the way the UUT is designed, and not a fault. If the green light comes on, you know you've located a valid signal. To clear the signal names from the display in preparation to touch another point, depress the push button on the probe. To demonstrate, we will induce a fault in the UUT by shorting address line 1 and data line 7 together. The display now indicates that fault. The probe address, probe data, and probe control tests are similar to Quick Trace. They cause the Fluke 90 to look for a specific address, data, or control line. To begin, select Probe Address and press Enter. The display will indicate which line to probe. When located, the display flashes the message, Found. The probe lights will also toggle when the selected line is probed, so you can run these tests without looking at the display. Particularly handy when you are working in cramped quarters. Press the probe push button or the Enter key to increment to the next higher line. The ramp test expands the fault coverage beyond the kernel, allowing you to test all drivers, address decoders, and the integrity of the bus up to the memory and peripheral devices. To execute the ramp test, press the bus test key until Ramp Test is displayed. To run the test, press Enter. The ramp test outputs an incremental bit pattern on the UUT address and data lines and performs a memory write cycle that enables any drivers, buffers, or address decoders on the UUT bus. This pattern can then be monitored with the Fluke 90 probe or with an O-scope. To run the test in a continuous mode, press Loop. This looping mode and all other activities or tests performed with the Fluke 90 is indicated by a flashing activity indicator in the lower right-hand portion of the display. By using the probe, you can monitor the activity on data and address lines. Lack of bus activity may be an indication of shorts or bad buffers. When using the ramp test, the data and address lines are toggled both high and low, so that as you move to higher address or data lines, the observed frequency is half that of the next lower line. We will simulate a problem by shorting address lines 10 and 12 together. Two lines shorted together will toggle at the same frequency. The ramp test can also be used to verify that the UUT's address decoders are operating properly. If you suspect there may be shorts between address and/or data lines outside the microprocessor kernel, you may find the shift test useful. Refer to your Fluke 90 User's Manual for additional information on this test. The Fluke 90 tester can be operated remotely by connecting it to a host PC or terminal through its RS-232C interface. In this mode, all commands are issued at the remote terminal. Some additional test routines are available in this mode which cannot be generated locally at the Fluke 90 keyboard. By now, you should be ready to try the Fluke 90 for yourself. If questions come up, refer to the User's Manual. Everything you need to know about operating this powerful digital tester is available to you there. And welcome to a new world of time-saving convenience with the Fluke 90 digital tester.